Hello and welcome to this second awards session as part of the buildingSMART International Standards Summit in Lillestrøm 2023. Thank you for joining. My name's Claire and I'll be your moderator today. Before I start, I'd just like to say the quality of the entries this year has been outstanding. So if you're sat here now, a huge congratulations and yeah, good luck to everyone. So in this session, finalists from the Design for Buildings and Design for Infrastructure categories will present their entries. This session is scheduled to last 90 minutes, including for time for question and answers from the elite jury after each category. Before I hand over to the speakers, I'd like to remind you that this is a hybrid event. For online attendees, your microphones will remain muted for the duration. For the attendees in the room, please keep background noise to a minimum. And if you wish to make a comment, please raise your hand. So without further ado, I'd like to invite the first finalist, and that's from Spol Architects.
Hello, I'm Raissa, and I'm partner of Spol São Paulo. And this is my colleague, Gustavo Oliveira. He's the BIM manager. We are responsible for the implementation of BIM in our office, and it's a privilege today to be here speaking with you. We are very honored. So, we are Spol, an architecture firm that with branches in São Paulo and Oslo, as our name suggests. Some of you from Oslo may be familiar with my partner, Adam Kurdo. Our areas of expertise are architecture design, interiors, landscaping, signage, and project management. And here are some projects that we act as a wider portfolio. But today, we are here to talk about a very different reality because we are presenting our work in BIM with Brazil. This is São Paulo, is the largest city in South America, and we are facing a lot of difficulties in the BIM implementation there. This is some. The conditions are very different from here, and especially in the construction sites that we still are doing very manually the work. And also in the perspective of the client, they still haven't seen most value in the BIM implementation. So we had a phase 1 in Spol working BIM. It was just about designing, documentation, and 3D visualization. And it was for the last 5 years. When we start this project, we have made a shift when we realized that the only way that we could help and really make a different situation in the Brazilian perspective of BIM, if we get the full responsibility about the process. So we act as BIM coordination in this project, and every project in our office starts with the viability study. So we are now in the BIM Spol phase 2. So our ambition is to push the whole chain to this new perspective of being that we are seeing here. So this is us really trying to move things on. I will let Gustavo continue.
Well, this is the project. The project is high-end real estate marketing. It's a project mixed use. We have 2 towers, one tower with 4 apartments per floor, and another one with 6 apartments per floor. So you can see the 2 towers together. The area is about 16 square meters. Another one. Now about openBIM information. This is your software ecosystem map, and in architecture design we choose for ArchiCAD, and to visualize it, Twinmotion and 3D Max, MIP Revit, and TKS structure. TKS is a Brazilian software specific for structure engineers. CDL use Construmanager is another Brazilian software. We use IFC to use our virtual reality and augmented reality. So with IFC and 3D print models, and to coordinate, we use Solibri for diagnostics and model validations and clash detections, and BIM Collab to issue management. All comments, models was exchanged were done with openBIM, use IFC and BCF. This is the model. We have 32 IFC models were developed. They are divided in 3 containers of information, divided in disciplines and in tower, floor plan, and basement, and was managed to more than 3,000 BCFs. This is our process map. The process starts with the client's briefing. So architecture presents the concept, and then we export the data studio and Trimble Connect. It's an internal workflow we create to do this work in the beginning of the process.
This is our area tables. So we are working since the beginning.
I will show an example. So that's it. We also export the IFC file and send the link to Trimble Connect, and it's export together a CVS file to put in Data Studio. And so the client can open the files and make the decision together. So it's a way to give the opportunity to the client to see the BIM files and the numbers even in the beginning of the process. After the approve, we have information about the client requirements and the project requirements. So with all this information, we make a BIM execution plan as a coordination, and then a kickoff meeting, another kickoff meeting. The next step is the needs reports of all disciplines involved, and we export the BIM architecture model. Okay. In the second part of the process, first of after the architecture model, we have another disciplines like structure and MIP, and we have quality control with Solibri and Solibri to make this quality control, and we use BIM Collab to concentrate the issue management. This cycle is repeated according to the number of the project phases. So this is a demonstration of the comments. In the final part of the process, we have a, sorry. We have a simulation, quantity takeoff. And the budget validation, and then construction documents. So the process is in. We also use some techs, adopt the BIM work process, facilitates the use of immersive technologies like virtual reality, augmented reality. And we have been working on bringing BIM and technology to the construction site. We go there and teach the construction workers. It's a...
Dois dedos, faz assim, então faz dois dedos juntos e aí você movimenta. Um dedo você gira, né?
And all of those softwares are free for them to use in any cell phone or tablet.
Yeah. Example of virtual reality. And 3D printing.
We use that the models on the concept phase and bring to the client in the beginning.
Yeah,
of the project.
we open the IFC file in the software of the print and export to the machine.
So we understand that our job in this process is to democratize the BIM in Brazil. So, So we are trying to bring the technology and what we can offer to them. So we really have the disrupt, as you had here, there. So we always work with openBIM platforms and softwares, and we start we start disseminating the openBIM to all stakeholders since the beginning of the project, bringing to the client that are contracting us and to the labor force in the area of the construction. So this is it.
Thank you.
Thank you.
Thank you, Raisa and Gustavo. So the next finalist in this category, Design for Buildings, is Finavia. So I'd like to welcome Mika, Juha, and Tommy to the stage.
Thank you, Claire. Excited to be here. Good afternoon to the audience and distinct jury members. My name is Mika Leppänen, architect from Finavia, which runs all 20 commercial airports in Finland. With me here, I have Mr. Eucaliptos, leading consultant from Sitowise Group, and Mr. Tomi Henttinen, Chief Innovation Officer from Gravicon. So our entry is Helsinki Airport Development Program. What is it all about? The 10-year-long program was launched in 2013 as the largest extension program in the history of the airport. Finavia's investment of over 1 billion euros has enabled Helsinki Airport to serve 30 million passengers each year. Data exchange across domain borders through openBIM was Finavia's requirement and strategy, utilized from the beginning and throughout all stages of the development program. Next, I have a short introduction video about the project and its goals. Here's project phasing and early master plan. More about project objectives. Planning was guided by sustainable development goals. Here's extensions, map, and program in a nutshell. openBIM models with gaming platforms were used for planning and training purposes for efficient airside operations. Here's some final renderings. Our new terminal. This is the last phase, just finishing this month. And next, I have a video about the construction in virtual mode that we did beforehand. The data-based 4D schedules were created for the whole project's framework phase and internal works. Virtual construction and usage of takt time planning methods brought productivity and construction efficiency to the next level. Using innovative video gaming technology and virtual safaris during design phase helped the project in gathering feedback and improvement suggestions from all the airport stakeholder groups. In addition, the safaris enabled uninterrupted operation of the airport and de-risking the start of new operations, as well as smooth integration of new equipment. Also, a unique MOVI solution was developed to support the maintenance of premises when they are completed. It's a new user interface which combines the data from the existing facility management softwares and the building information model produced by the program. Juha continues now.
Thank you. Since 2007, Finavia has been the forerunner in application of the national BIM guidelines for buildings in Finland. In the master plan phase 2014, the Finavia openBIM strategy was drawn up for the entire development program, and also with the infrastructure outside the airport. The strategy set common objectives and requirements based on national GoBIM and common InfraBIM guidelines, terminology and classification, integration between building, infrastructure, airport domains, and terminal airside coordination processes taking into account different disciplines and also types of technology. For openBIM data exchange, IFC in the terminal side and IFC and land XML-based infra model in airside were used. Then some highlights from the air side. There are challenges, especially in the interface between terminal side and air side. Different units, project schedules, different level of information need. This requires strict rules on both sides to coordinate processes and content, and also resources for information management on both sides. At the apron level, a major effort was the compilation and modeling of the initial data model from spatial data in the maintenance systems. There were lots of different existing underground networks and structures. The workflow also covered the entire life cycle from as design to construction, machine guidance models, and further to the as-built models, and back to maintenance systems as spatial data, and back to initial state model. Then a video. Again, openBIM data from the design phases were redefined into virtual environment, a gaming platform. The virtual environment worked as visual dashboard for the project management and supported design and construction in constructability and placement of equipment. The virtual environment facilitates transparent decision-making, leads to a common understanding, and makes it possible to gather comments and hold on an open discussion. As a special highlight we can mention was the introduction and training to functionality and accessibility to airport for maintenance staff, authorities, operational and transferring services. And that's not just a video for watching. You can yourself drive the car, or the pilot can control the plane in different circumstances. Sunshine in the daylight, darkness of the night, or different weather conditions.
The project contained several new terminals and refurbishment of existing terminals in Helsinki airport. Kravikon was a BIM coordinator in all of these sub-projects. The whole design work in the project was carried out using software tools that support openBIM and IFC specifically. We had dozens of different tools used. We had dozens of different design offices involved in the project. We handled the data exchange using IFC and BCF. We had thousands of IFC models during the process, during the 10-year process, and tens of thousands of BCF issues that we managed together with the site management and the principal designers of the project. So, and behind of that was the Finavia's consistent BIM strategy, which gave a kind of solid ground for all these activities. Finavia has a big focus in user experience because that's their main kind of a market that the passengers who pass the airport need to feel that the airport works properly. So, for example, these virtual safaris, which I already mentioned a couple of times, were used to make sure that all services and all activities in the airport work well. At the end of the day, the project is now finalized, but the openBIM models, they keep living because airport is a living organism. It keeps changing all the time. So all these openBIM models are still in use in the maintenance. Like Mika mentioned, there was a development of a special tool tool that is now used. It's based on like a gaming platform, but it's utilizing the openBIM formats, and the models can be updated and bring to this new system, and they can use that in when they are doing the maintenance and daily routines at the airport. Here are all the stakeholders and parties involved in the project. Like you can see, there are dozens of different organizations, and most of them were also involved in the openBIM collaboration within the project. Thank you.
Okay, please make your way along the stage and we'll bring the others back on, and then we'll have time for some questions. So I'll open the floor to the jury in no particular order.
I have one question for the second project, the Helsinki airport. You used IFC 2x3 all the way through the project, and I guess that's because the long time the project runs, probably. Did you ever consider to switch to a newer version, and how is that for the as-built models that you obviously created? What's the long-term usability of for the maintenance also?
To be honest, no, we didn't think to move to IFC4. The main reason is not IFC4 itself, but the authoring tools that were used in the design process. Most of the tools at the time when the design was done didn't support IFC4 at all. You have to remember that now the project is now finished, but the design work mainly was finished like a year ago or maybe 18 months ago. So yeah, the tools were not ready for that. And at the end of the project, maybe some of the tools could do that, but of course it's quite risky to change the format at the end of the project.
So you had a challenge to get into a current situation of construction in Brazil, of course. So I was wondering, you showed iPads, and was there paper used for the current constructor to actually be able to use it in that way, or was it pure digital? That's one part. And the other part, did it stick? Is this going to be helping the industry in Brazil to take the next step in working this way?
Yeah, we believe that the BIM is not for design, for construction. The BIM have to be in our project phase. So we try to put when we work, and we work in design, like architecture, coordination, and sometimes we have this opportunity to go to the construction sites and
Yeah, they currently are using paper, and if you go there, but when we in our projects, when starts the construction phase, we go there and we
show the tech.
yeah, we show everything, and we manage them to that if they want, they can use, right? Because it's like available. It's not like very high cost for them.
Sometimes we have a BIM models in the project, but the construction sites don't know anything about this. So
yeah, that's very common in Brazil.
Yeah.
You have the BIM sometimes, but they are not. It's not being used in the construction field. So that's our.
We try to
Yeah.
change.
May I just add to the question before that you have to remember that at the airport project we had like an ecosystem of software packages used. We had hundreds of contractors who were using BIM on site with different tools, like hundreds of different software packages. So and sort of the common denominator between all these packages was IFC 2x3. So.
Well, first of all, testing. First of all, thank you. Thank you both for sharing kind of like the Brazilian, a new chapter, some of your local challenges, and how you work in that in a residential project with your unique challenges. And thank you also for the Finland group for showing not only how this is a 10-year commitment, but also how you contribute to national standard and global standard. A question, if time permits, to both teams is that, can you give us one specific, quantifiable example of what were the benefits of openBIM supporting business impacts or supporting sustainability outcome? Can each give one specific quantifiable example, please? Maybe first project, yeah. Vasil?
I believe when we have open data, it's available where, and doesn't matter where and what kind of software you use in the future. It's the most benefits of use the openBIM concepts, because today we have some softwares, tomorrow we don't know. So we have this database, it's very important.
Maybe I could say that there are lots of benefits. Of course, the maintenance, because the life cycle is long, and the maintenance, you can raise that up or take that up. But if I just analyzed during the project, I think that one of the biggest kind of benefits was that we were able to keep up the schedule, because the airport was running all the time. So it's a place that is running 24 hours, 7 days a week, and so in order to kind of do the construction works and still serve as a passenger hub, it's a challenging task, and then that was one of the great benefits of using BIM, that we were able to keep the schedule. Of course, the budget as well was quite important for Finavia, but I think that I think even more important was that the parallel sequence of construction work and the airport daily activities?
Yeah, we actually managed to keep the customer experience ratings that we do all the time. We ask customers, we managed to keep the ratings up in the high level. So there was they didn't come down.
I guess to complement, I don't know, to add in response to, I guess it's the openBIM, the best value is the democratization. So everybody with any open, like free software can visualize or extract that data. So it's really for all.
Any further questions? If there aren't, that's absolutely fine. Yep. Okay. Then thank you for your questions. Thank you for your presentations, both projects.
Thank you.
Thank you.
And we will get started with the next category.
So the next category is design for infrastructure, and our first presenter is Huisong Wang from China Rail Engineering.
Thank you. Good afternoon, everyone. This is Huisong from China Railway Eryuan Engineering Group Company, and I'm very glad to present application of openBIM in the design and delivery of the second Chengdu-Chongqing high-speed railway. And the first part is project overview. The second Chengdu-Chongqing high-speed railway is located in Sichuan province in China. And this railway is 400 kilometers per hour high-speed railway connecting Chengdu to Chongqing. And this is also the first 400 kilometers per hour high-speed railway in China. And the length of the railway is 300 kilometers, and the total investment of 70 billion Chinese yuan. And the project is a key large-scale infrastructure of the Chengdu to Chongqing economical circle. Due to its particularity of being built across mountains and rivers, it has high requirements for the environmental protection, safety, quality, and sustainability during the construction. And in our project, the design company is China Railway Eryuan Engineering Group Company, and it's also my company. And the owner of this project is Yangtze River Coastal Railway Group Company. And here I listed some highlights for this project. The first one is ISO 19650 was adopted throughout the whole process of design and delivery. And the second one is a common data environment for design and delivery was developed. And also IFC files were used for information exchange. And the next is the transition of project collaboration from file level to data level. And then based on this project, the data requirements, use cases, IDM, and UML of railway were standardized. And we also achieve multi-domains BIM design. And the next, we also established the electronic set table, and it plays a very important role to BIM supporting decision making. And the next is rapid BIM modeling. And the last is the simulation of railway gauge clearance checking, single availability checking, and video overlay, and etc. We follow the steps of ISO 19650 standard. Firstly, we achieve contract agreement, And then we define information requirements, and the next we produce BEP. According to the requirements of the owner, and the goal of this project is to use openBIM technology of achieving a whole project, all domains, and all phases digital design, and optimize digital application and maximize the value of openBIM in the process of railway engineering construction. So in order to achieve these goals, we adopt the information management process of the ISO 19650 standard before start of the project, and starting from the information requirements of each stakeholders. So we developed a BIM execution plan by using openBIM methods such as IFC, IDM, and the BCF, MVD, and so on, to support the collaboration and the interoperability across all stakeholders. So this is the process map for our project. And we also produce IDM and the corresponding exchange requirements. And we established the project CDE. And from this picture, you can, it's our software ecosystem map. And you can see from this picture, there are many tools. For example, project-wise, we use it to use it for a collaboration management platform, and such as OpenRail Designer and Revit. We use these tools for BIM design. And we established a BIM component library for railway. And we also use BSDD to add additional extension on IFC. And we also use openBIM methods such as UML, MVD, and XML for IFC rail extension. And we also develop a components management platform for BIM components uploading, review, and auditing. And we also achieve multi-domain BIM design of alignment, track, subgrid, bridge, tunnel, signaling, and telecom, and so on. The next is the BIM design. For example, this picture shows the model of geologic model. And this is the model of alignment, subgrid, bridge, and tunnel. And this is the model of station building. And this is the BIM design of signaling, telecom, and energy. And we established the electronic set table platform. And the electronic set table integrates the geographic information, regional geology fault zone, and band geology, and track network, environmental information, and BIM data of the whole project. And also it helps to quickly find the engineering information and use 2D and 3D linkage to achieve a model review and schemes comparison. And the next, we also deploy BIM standards in our project. For example, we use international standards such as ISO 19650 and FC 4.3, and we also deploy CRBIM standards in this project. And in this project, we have defined 24 use cases. And here I introduce some important use cases. And the first one is clean detection. Based on the BCF standard, correlation detection is carried out during the process of the design phase. And this is a use case of route selection. We use this use case to analyze the advantages and disadvantages of each scheme and assisting route selection. This is a spatial analysis. And the next is simulation of analysis of crowd evacuation in a station. And the signal availability checking simulation. The video overlay simulation. And this is a simulation of drainage analysis. And we also have design simulation for protecting dangerous and falling rocks. And the last use case is visualization. Then we choose use case to test. Our project team and the software vendor jointly completed the FCSWS standard testing and verification. First, the project team put forward the V-type technique routes as follows shows. And in the project, we selected 4 scenarios, including detailed design, correlation detection, quantity takeoff, and 3D visualization to verify FC standards. These are the 4 scenarios we chose. In a test, we carried out the FC import and export test on the BIM software platform to verify the integrity of geometry and attributes in the process of FC import and export. The next part is digital delivery. When the design phase completes, the design models and the drawings are automatically published by the CDE platform in the format of FC, DGN, DWG, and XML files. A delivery list is also generated at the same time. So this shows the openBIM data matrix summary of our project. You can see from this slide here are 6 domains in this project, and the number of model versions is 9. And we also have 39 IFC files. The size is 1 GB, and we have 76,053 objects and 29 BCF topics, 420 entities with 835 pieces. So this is the business value of our project. First, we through the use of openBIM methods, the efficiency of modeling is increased by more than 30% compared with the traditional way. And by using the digital delivery, the waste of paper printing is reduced, and the communication among all stakeholders become more easy. And the third one is by taking ISO 19650 and openBIM standards, engineer understand the design idea more better. And the last is we achieve data sharing among different stakeholders. Each stakeholder can import and export BIM data in standard format. The last is the summary. openBIM were fully used during the project to help project manager with data integration, data analysis, and decision support. The second is this project is a successful application of ISO 19650 and openBIM solutions, and will provide a typical example for the digital construction. And the third one, based on the openBIM method and the process, the second Chengdu-Chongqing high-speed railway project has achieved information integration and providing valuable experience and lessons for the digital transformation of future railway projects. And the follow is a very short video.
With a length of 276 kilometers, the line has 2 existing stations and 4 new stations. The ratio of bridge and tunnel to line is 75%. In this project, BIM technology is professionally applied to railway design. The alignment model is firstly established, and then the bridge, the tunnel, the subgrade, the signaling, and other specialist areas are designed based on the infrastructure model. Multi-specialist area BIM forward design is achieved. The design and production process based on BIM technology is obtained, and the online design scheme review based on BIM's results has also come true. A set of standard structural trees suitable for railway engineering projects has been innovatively drawn, specifying a way of expressing BIM model information, the information structure definition, and the component information relationship among different specialist areas with data sharing and interoperability. We deploy the standards of buildingSMART and CRBIM in a collaborative design environment. The attribute research of IFC model under different accuracies was carried out, while information exchange, design review, and other functions are extended. Design standard unification and information sharing among different specialist areas is thereby achieved. The team has identified 24 use cases closely related to railway application scenarios, covering the whole life cycle stages of the project. IDM has been produced, requirement exchange has been identified. The team has completed testing and verification for application scenarios. Detailed design, collision detection, QTO, and 3D visualization are selected to verify IFC standards. The integrity during IFC import and export is verified.
Okay, at last, I would like to thank you very much for our team members. And that's all. Thank you.
Thank you, Hui-Song. So our next finalist in this category is SYSTRA, and Beatrice is coming to the stage now.
So good afternoon, everyone. My name is Beatrice Tiberi, and I'm working as a BIM manager in SYSTRA SWS, which is an Italian branch of the SYSTRA group. I've worked in this project as BIM manager since the tender phase up to the completion of the detailed design activities, which ended up around the beginning of this year and still ongoing for some bits. So in this short presentation, I will try to highlight the most important points of this work that has been so important for our company and for me personally, since I've been working with it for 4 years. The project is located here in Norway. It's about 1 hour southwest of Oslo. And it is the extension of the existing railway line converted to a new double track high-speed railway line that will connect the town of Nykirke to Barkåker. We were the main designers for the construction company joint venture Sapinor, made of WeBuild and Pizzarotti for the owner Banenor. The project consists of about 14 kilometers railway line, double track, and with several permanent roads and temporary deviations, as well as temporary roads for site works. The structures included 2 rock tunnels and 2 cut and cover tunnels, 1 brand new railway station at Horten, and 2 railway bridges, 1 pedestrian bridge, and several smaller structures, concrete structures and geotechnical works. As I mentioned before, we were the main designers for this project. So all the disciplines that you see on the right part of the screen were on us. So one of the major points and challenges in this project as a model-based design and build project was to coordinate all those different disciplines and all the different stakeholders involved in the project. So to start with this challenging project, we decided to set a common ground on which all the parties could work together. And this was defined since the beginning in the BIM execution plan, trying to standardize all the designed items that were to be in the project. We worked at an object level, defining a common database in which all the designed elements were assigned a 2-digit code under a parameter that you see in these examples was called object ID. That gave a clear identification of each single part of the design. And this database of information was shared with all the parties in the CDE, that in this case was BIM 360 by Autodesk, and was available as a live document to all parties so that the data was open and accessible by all the parties involved. Since, I say it again, it was a model-based design and build, and this meant that actually the design activities were very close to the construction schedule and the construction activities. So this also demanded for the need to have the right timing in coordination and smooth processes between all the parties. Working at a model level, the IFC was the official deliverable, also as requested by the appointed party, Banenur. But I have to say that since the project started back in 2019, and 2.3 was the schema that was used for the project, no infrastructure standard was available for IFC. So we ended up forcing the IFC building standard to the needs of an infrastructure design, creating the database and the connection between the object coding that we saw just a few slides before to the IFC classes and IFC types of the building, of the IFC building standards. And again, at the data level, we focused a lot on including all the information in a simple and a clear and usable way for, again, all the stakeholders, because this model was not only meant to be used by the design teams, but also on site by the contractor and by the owner to, for different kind of uses. So what we defined were these 5 property sets that you see in the red table that contained all the information that were needed for the different parties. And since this was a model-based project, the production of 2D documentation, drawings and reports was very limited. So all the information were to be inside the IFC models. And you can see here an example of the new Horten station and some of the information that, for example, in this case, are assigned to an element of type IFC wall with all the information about the characteristic of the concrete in this case. With this structured way of managing information and defining standards between all the parties, we were also able to introduce in this project another standard, which is the MMI, or Model Maturity Index, which is an index that is widely and rapidly spreading in the Scandinavian countries. And it was an important parameter because it allowed us to monitor and control also the development of the design, merging together the LOD and the LOI, so both the geometrical information and the data information of each element from the preliminary phase, so the MMI 100, up to the ready for construction MMI 400 and as built elements MMI 500. So this process led to different uses of the models, which were, for example, the ability to access all the data via the discipline models and the IFC models. This means that all the disciplines models delivered in IFC were available on the CDE and also merged together in a coordination model that was updated constantly. And that was the basis for all the parties to coordinate and to discuss the design and construction phases and so on. And we linked also all the not modeled information inside the models with some connection to the documentations which were stored on the CDE. Also, this kind of data structure allowed us to manage information and data for different purposes, for example, for quantity takeoff, but also for simulations and to perform design analysis. And the process of delivering the IFC as design deliverables also, of course, included the process of internal review that was carried out with, in this case, BIM Collab Zoom. So it's a free platform that allows to manipulate or to analyze IFC files in a very straightforward way, and that was used also on site by the contractor, and to quality check all the designed elements. Of course, also the coordination of the different disciplines has been performed via the IFC files, and not only in terms of clash detection as hard clashes, but also in terms of design checks, in terms of clearance distances, minimum and maximums allowed distances, and so on. And this, of course, allowed us to handle a large data set of information and models through a railway line that spreads for 14 kilometers. And since this was a model-based design, we had this collaboration platform also for issues management, which is BIM Collab. The platform was accessible by all the parties involved in the project. So the process was transparent to all the parties, and all the issues were there and were used to keep track of the process of the design of each area. The tool also, of course, allows to import and export BCF files, which is an open format for issues management that can be imported again in several different native softwares or authoring software, check-in softwares. That really eased and allowed for a smooth collaboration also internally with our design teams by sharing the BCF files with all the design issues to keep track of. And this is a small summary of the process that we followed. As you can see, we had several authoring softwares involved in the design phase, but this didn't, of course, prevent us from delivering coherent and consistent IFC files, since the definition of the standards since the beginning allowed to deliver a consistent output from each of the authoring softwares. This was also reached with the use of some scriptings and some in-house built tools to check and handle and work with IFCs 2.3. The coordination process, as I said before, was carried out mainly through Navisworks and WinCollab, always working with the IFC files, and then shared on the cloud with WinCollab. If everything was okay, then the open files in terms of IFCs and land XMLs together with BCF, if some information had to be shared also with the site, were sent directly to the contractor, which used the model as input data directly for the machinery on site. And to sum up with some numbers, the model delivered were about 350, which is quite a large number for not a very long project, because only 14 kilometers. But since it was a model-based detailed design, we really had to deliver detailed models with lots of information that also led to heavy files, because data sometimes it's heavier than geometry. So to keep files manageable and usable on site, we delivered a small section of the project, but very detailed. And models were created mainly with 5 different authoring softwares: Civil 3D, Revit, NovaPoint, MicroStation, and Sierra Soft Roads, covering more than 20 disciplines. So I did this in a very short time. I still have 1 minute to go. But this is the 3 of us that are here today. So if you want to have some clarification or a chat with us, this is me, and my colleagues Alessandro Menozzi and Francesco Pinelli that are sitting in the middle of the room. Thank you.
Thank you, Beatrice. So for the final presentation in the design for infrastructure category, we have Tina, Jonathan, and Fabian from ILF Zurich.
Good afternoon, everyone. It's an honor for us to be here today to present our tunneling project to you with a focus on the way we used openBIM. Us, that is SBB, and the joint venture IG Brütt. I'm here today with Fabian Kleigner and Jonathan Dunn from our lead partner, ELF. My name is Tina Black and I work for SBB and I'm the Deputy Project Manager. We take you to Switzerland today, the country with the Gotthard Base Tunnel, with 58 kilometers, the longest railway tunnel in the world. But today is not about this tunnel. We talk about the Brüttener Tunnel. It's a 10-kilometer long tunnel between Zurich, the biggest city in Switzerland, and WINTERTHUR. This is the key route in the Swiss railway network, and it currently has only one double track, the black line in the picture. And that has reached capacity and cannot take any more trains. However, to meet the forecast of increasing railway traffic, an additional double track is needed through the Brüttener Tunnel. The 10-kilometer long tunnel is designed in a Y shape with 3 portals and an underground junction. It consists of 2 single-track tubes, and each of them has an outer diameter of about 10 meters. The 2 tunnels are connected by 20 cross passages, which are needed for the tunnel safety. The whole project, that is the tunnel and the upgrade of 4 adjacent railway stations, cost roughly 2.8 billion Swiss francs. Thanks. When the joint venture IG Brütt and SBB started working together, we were both committed to model the tunnel in BIM. For SBB, with the many disciplines involved, it is crucial to focus on openBIM. In 2017, we started off making a test model of one of the 20 cross passages. As this test run was successful, we moved on and modeled the entire tunnel in BIM. This was mainly used for coordination between the disciplines and to solve conflicts early on in the design process. Having successfully finished the conceptual design phase, in the permit application design phase, the entire tunnel was modeled in BIM and it was used as our single source of truth. That means the whole design was done in BIM, and only later, when the authorities, who unfortunately still need 2D drawings, we derived them from the model. Also, for us as client representatives, one of the main advantages was that we could use the 3D model to make our project more accessible and understandable to stakeholders and landowners. We could also use the openBIM and IFC format to exchange the files with a third party to create customized visualizations. Now in the tender phase, we can automate the determination of quantities from the model, and we have a more stable project which will hopefully lead to less changes during the construction. The construction phase, which will last roughly about 10 years, we anticipate a more efficient collaboration between the contractor, the design engineers, and us. I will now pass on to my colleague Fabian to go into more detail on the openBIM information.
Here we see some key facts about the project. We used Catenda as our central CDE platform for coordination. For many disciplines, it was one of the first major BIM projects. So it was a big challenge for us to involve as many project participants as possible with simple tools. A lot of development work was invested in defining the object types and the property sets, which could then be used as a standard catalog for the client SBB and even for the IFC tunnel development. When modeling, we focused on a small memory size, ensure the necessary performance and handling. This illustration shows the openBIM workflow. For modeling tools, we mainly used Revit, Civil with Dynamo for civil engineering, and the other disciplines used their own software, mainly Nova. After this, we checked the data from all open files, like IFC, CSY, or JSON. With simple tools like SimpleBIM, we were able to structure the data so that we were uploaded cleanly to the CDE Catenda in order to coordinate the platform via BCF. There were also links to the client's SBB SharePoint and to the virtual reality VREX. Then the feedback from the coordination process and the resulting decisions were then integrated back into the model process. The main use cases during these 5 years of the project has been design coordination, with the model as a single source of truth managed through the exchange of BCF issues. The coordination process covered the classical construction disciplines like civil, architectural, geotechnical, and geology, together with all relevant railway disciplines listed here. And the data from open GIS sources with land use, existing buildings, roads, and structures. Together with administrative and land register boundaries. You see here. Now I hand over to Jonathan Dunn, who talk about the key objectives and outcomes.
Okay. The SPB's information requirements have evolved over the last 5 years of the project, but from the very start, the most important objective of the SPB's project management was that we actually encourage SPB staff to use BIM. We needed them to actually use the model. It sounds kind of easy, to be honest, but in Switzerland, particularly in infrastructure, the majority of engineers at a kind of decision-making level remain skeptical about BIM and model-based design in general. And it was obvious that we had a huge task to sell the concept. And we were pretty aware that we could easily get lost in a kind of BIM bubble where we were just preaching to the converted and not actually getting to the real people we needed to convince. We made an early commitment to use a model-based design process to actually plan in 3D and not just use 2D as usual, kind of with outsourced modeling. We also took concrete steps to make the model easy to understand and to navigate and to structure it for future use. We evaluated several CDEs and in the end chose Katenda as the one that we found the most intuitive and easy to use. And then together with the SPB, we developed a so-called technical project structure plan that was based on the SPB's data bank of fixed assets. And we then mapped the structure onto IFC spatial containment structure. This basically then provided us a kind of geographical discipline-based structure that made it easy to isolate and filter individual parts of the project. And also in turn, every single element in the model has a unique human-readable name based on the structure plan, on the discipline type, and on the object types. In addition, we added sort of what we call sort of spatial cards along the model, basically every 100 meters at the stationing, which allowed users to navigate anywhere easily along the tunnel. And as spaces, they can be turned on and off in the CDE. In addition, we also added cards at all changes in cross-section, everywhere the track changed, everywhere the power supply changed, at any particular installations, cross-connections, signal locations, anywhere of interest, we had one of these spatial cards. And because they're normal to the axis, it allows a normal user to go directly to it and actually make a cross-section exactly at that location. The key outcome has been that users were actually able to use the model and use the model with very little training. We had people who had never seen a BIM model in their life, and within a few minutes, they were actually in the model finding their way around. The next benefit is the model has actually been used as a primary source of information. And we found that having a clear structure to everything has ensured that the models are intuitive, they're easy to use in the coordination project process. And this has in turn allowed us to actually use the model for all sorts of extra use cases that actually arrive out of the need of the users. A particular example is this one, where the SPB signaling department wanted a visual and not automated, a visual evidence of the line of sight of signals. And it took maybe 10 meetings till we actually found what they really wanted. And this actually involved modeling the driver's position, the signal position, and making a semicircular ray from the one to the other and seeing where it actually clashed with the tunnel walls. And the distance is based on 160 kilometers an hour. And this can actually be viewed in any IFC viewer. It's basically given up as an IFC file and previewed anywhere in any kind of software. And the process was actually so successful that one of these signaling guys who'd never used the model in his life suddenly said, okay, that's it. From now on, we're incorporating it in our usual workflows. Another example is the SPB identified next to one of the portals an area where we could actually deposit 500,000 cubic meters of tunnel muck right next to the portal, which avoided thousands of truck trips and the noise involved. And by extensively landscaping this area, we were able to upgrade it to a sort of valuable recreational space. We modeled over the 3 years multiple alternatives, but we were able to give the updated IFC model to a company called Inside Reality that incorporated them virtually in 48 hours into a visualization model that was then viewed by the public in a dedicated kind of 3D room. And it's actually been absolutely essential for selling the whole concept of this disposal area to the public.
As an information container, the WINTERTHUR tunnel has been used as a test bed for the implementation of data models at several levels, both within the SBB and also because internationally, through our involvement in IFC tunnel, we've actually used it to test things in IFC tunnel. And part of this whole process, we realized it's so important to try things out and to test them, to be flexible, to be open to criticism, to make changes wherever necessary, to make sure that the final outcome that we have is accepted by the users and not simply imposed upon them. And by targeting the audience specifically, we've been able to successfully spread the idea that a three-dimensional single source of truth information container will actually add value to any project. And I guess finally, most of all, the most important outcome is that now openBIM has actually been firmly established in the SBB's tunnel design processes, which is now paving the way for us to use it in the construction process, and most importantly, for information management during operations and maintenance. On behalf of us all, thank you for listening. Yeah.
Thank you very much. If you'd like to make your way further down the stage, and I'll invite the other presenters back onto the stage for the question section. Okay, jury members, over to you.
Yes, thank you all for the presentations. First, I have a question for the first project, the China Railway project. I'm always interested in the software that you use, and you mentioned a couple of software solutions that you developed during the project, even like a CDE, a component library, a management platform, electronic sand table platform, and a GIS platform. And also this V model where you connect the communication between domain experts and developments. Can you elaborate a bit more on the software that you use that's already existing and what you developed in the project beyond all the data that you created?
Oh yeah. Actually, we established CDE in our project, and I think it's very valuable for this project because the CDE helps us firstly collaborative very well, and also we can generate the final deliverables from this CDE system or CDE platform, and I think it helps a lot in this project.
Yes, for me also, thank you for the presentations. I have two questions for basically all of you. I think that the Swiss delegation answered it already. This is a fairly new development, all rail and tunnel. Do you all bring the experience from the projects back to buildingSMART for the railway development? You said this is a test bed for IFC tunnel. Goes that for all projects?
Shall I answer? Yes, particularly, and particularly because of the railway involvement. We're specifically involved in IFC tunnel because we're essentially tunnelers, but the whole thing is for being a railway with the whole stationing along an alignment. We also part of BIM. The SBB has a program, BIM at SBB. It's been mentioned at IC Rail today. But we as an external firm are working in the BIM SBB process, and kind of a lot of it has been the feedback, the practical feedback, saying to people, hey, you know what, he has a problem, it's difficult to do this, how do we do this, how do we do that? Kind of, really trying to give a practical feedback to the actual implementation of this stuff, yeah. And yeah, a lot of the feedback, because it's such a journey, yeah.
Do you have any additional?
Okay. And in our project, I think we used the IFC from start to the end because I work in IFC rail project, and I think it's a very good chance to combine the IFC rail standards with our project. So from start, we define different kinds of requirements according to the requirements of our owners. And in the process of our project, we also have some modification or improvement for the FCGL standards as well as our CRBM standards. Yeah, I think it's a good tool for us.
Yeah, I have to say that I agree with both answers, actually. We as a group are involved in the development of the IFC rail standards. This project that I presented today was not maybe the best example to provide this experience, to bring this experience to the development of the standard, because we were designer for the understructure part of the railway. So no overhead contact line, no top level of the railway. But yes, of course, other projects in our company will contribute to the development of the standards. It was not the chances this project, since also the standard was a bit immature at the time.
Exactly. So projects help to develop with each other.
Yeah.
I have one more question, if I may, because you all have to do with geographical information, which is you're trying to create something new in a landscape that you may not know everything about. Is that geographical information available publicly? Some of it is, maybe some of it is not. How much is that? Do you have to do it for the project all new, or is it available? Also for all three of you.
Should I go first? No. Actually, in particular, I mean, we talk about our own cases. In Switzerland, it's actually, particularly in Canton Zurich, we have got a very good GIS platform. And there's a lot of information available. Obviously, it's to get it into the right format. You rely very much on, there's no sort of easy way of doing it. But we for instance, have a member of our staff is very good with FME. So the kind of exchange from various data formats. But kind of it's one thing at a time. You know, we have a problem. He sits down, and once we've solved it, it takes maybe a week, 2 weeks to get it organized. But after that, it's, you know, and it's one, you know, it's ticking the boxes one after the other. But it's, you know, it's definitely, it's working, yeah. But you rely on having good public sources of information, which we are lucky in our case, yeah.
All right. So first of all, I think today we are celebrating the diversity to see from the earlier design for building to design for infrastructure. It's railway across the world, from shorter ones to longer ones, but yet it's all about contribution to openBIM. I do agree with my fellow jury members about how can you all contribute back to the buildingSMART community, working with emerging standard, new projects, how to bring it back. So I guess that's a recommendation to do it that way, to give it back and bring some of your project knowledge and insights and limitations you have overcome to the broader community. My question to each of you is that, have you been tracking your specific investments in openBIM, in overcoming some of these openBIM challenges, in coming up with creative workflow, or have you been tracking any of the return from your investment? Any sharing on either the investment side or the return side, or still a work in progress? So I would love to hear from all three of you. Yeah, maybe lady first from the left.
Yes, I also reply to your first question or topic. Of course, I agree that the contribution to the openBIM community, it's an important point for us, that we work as designers and we are in contact with the contractors, and we are on site and we do the daily work, you know, with the real projects. And we get to know the real needs of the market. So I think this is one important contribution that the designers firm can bring to the community. And for the second question about investment, I have to say maybe I'm not the right person to answer, because I'm involved as a BIM manager in this project. But our company has always invested in the implementation of BIM for at least the last 10 years almost. So it is definitely one of the assets that we are promoting in our company. And it will be something that we will invest on because it's profitable for our company.
Okay, I think the open BIM standards and they are also good enough today, but I think we should improve and refine especially the standards in our practical projects, and by step and makes it better. Yeah, thank you.
Quick short website. I mean, in terms of benchmarking and actually having costs, it's kind of obvious that it has cost us. It's cost time, it costs money. But on the other hand, we didn't get into it because somebody said we had to. We've been modeling things for over 20 years, and it's only been with the advent of openBIM that we can actually share the stuff we're doing. I've had clients 10 years ago tell me they don't want to see a 3D model and they're not paying for it. What's happened now is we're lucky because I think we've got an extremely good client with the Swiss Railways, and they have been prepared to invest and to try things out. And for us, I mean, as Fabian just said to me, it's part of our thing. Is it's nothing special. It's going to be part of our daily work. The goal is one day nobody's going to talk about BIM anymore because it is better. And the whole thing is being open, and we can share it, we can swap things, we can change it. And we have to get into it now. We have to use it now. It does cost money, but if you leave it, it's going to cost a lot more. So we haven't really got a benchmark, but what we do get, we have actually had very positive from the acquisition point of view. We do get jobs because people say, you know, so the returns are there, but again, it's a journey. We've got to see this to the end, sort of. Yeah. Thank you.
Okay, thank you for your answers. I can see we're at time there. We've got a quick turnaround for the next session, which starts in just over 5 minutes. So we will wrap things up promptly. Thank you for all your questions. Thank you to the presenters again, and we'll now go and take our deliberations outside to determine the winners. Thank you. See you all later.